EOS here, back at it again with another video. Last video, the first video I made, went really well. My channel actually quintupled in size from going from 1 subscriber to 5 subscribers. All right, now guys, I have to let you know, my channel is titled EOS. Now there is another YouTube channel titled EOS that has 498 subscribers. This is unacceptable. If my channel gets to 500 subscribers, beating the other EOS, I will release a roommate reveal. That is right. I will release a roommate reveal. Okay. Now that we have that out of the way, let's talk a little bit about program 6. Okay. So last video was program 5. This video will be program 6 for my computer science class. All right. So it looks like we're doing program 6 and the main topic is inheritance. So we got some specifications here. I'm just going to quickly read through it, and then as we implement some of these methods, I'll go a little slower based on each method. So usually when I start a program, I just kind of skim the requirements so I don't try to miss anything. So we're going to make a stack. So we're going to extend our dynamic array class to implement a stack. By the way, dynamic array was the topic in program 5. So in program 5, we actually made this dynamic array class, which stack will be built off of. So dynamic array will be treated like our parent class for this assignment. And for our not dynamic array class, but for our stack class, we're going to be implementing a size method, an isEmpty method, a push, and a pop method. We'll also be implementing stack dump. And then we're also going to have queue. So it's another child class off of dynamic array. Okay, yeah, okay, just making sure that was right. It's going to have an isEmpty, a queue, dequeue, size isEmpty, queue. Okay, so it looks like some of these methods are pretty similar from each other. And then we're also going to have to use a driver to test our class. Okay, so the name of this will be stack queue driver. And okay, so this is the driver class we'll have to copy. And then these are the outputs. So we'll have to produce the following output or something equivalent. So I'm assuming that these are the target outputs. So these are so the difference between like target outputs and sample outputs is that we actually want this exact output. Like we want to see pushing 1.1, 2.2, 3.3, all the way to 11.0 on the screen. So these are like the exact outputs that we want to see when we're done. So let's copy this driver. Not the target, just the driver. All right, now let's open up Eclipse here. So I already copied it in a different take, but I'm just gonna delete it and restart. So all I did is I went to new class and then I typed in the name of the class. The name of the class this time is stack queue driver. Then after you do that, you'll get a new class and you can copy paste it. And okay, everything works out just fine. So the only thing here, we have stack and queue in red, and that's because these classes have not been made yet. So we're going to get stack cannot be resolved to a type and queue cannot be resolved to a type. It's because Java doesn't know about stuff that doesn't exist. Let's close this console here to get more room. Okay, so from here, I guess we can start with the stack class and try to implement some of these methods. All right, let's talk a little bit about inheritance. So at this point in the video, we only have one class created that really matters. And the class that matters is array driver. So all a class is just a collection of methods and variables. So I'm just going to draw some pluses and minuses. These are like representing methods and variables, right? We just have a bunch of methods and variables contained inside of this class. The point of this program is to create 2 subclasses that extend the functionality of this main class. So I'm just going to create 2 boxes here representing subclasses. So these boxes are going to turn into stack and queue for the context of this project. Now, the purpose of creating subclasses to extend the functionality of the main class is to use some of the methods that this main class has. So we're actually going to be extending by using the keyword extends. So extends allows us to get functionality from our, it's not really the main class, from our superclass. I'm going to be referring to this big box as the superclass. The way we reference methods from the superclass is by using the super keyword. So super is how you reference something that you're extending to. Now, in subclasses, they can also contain their own methods and their own variables. So just pretend like this class has their own methods and variables. This class has their own methods and variables. This class also has its own methods and variables, but we're using functionality of their methods inside of this class to make these two subclasses more efficient. So these are subclasses. So for the context of the project, this will be stack and this will be queue. Sub. And this class will be the superclass. I think in other languages it's called like child class and parent class. And in that case, this would be the parent class and these two would be the child class. But I think super is cooler, a cooler word, so we're going to use super. So this is like the superclass, and this will be the subclass. So once again, the subclass will be using some of the functionality that is contained within the superclass. We'll be using these methods and variables in the superclass by using the super dot keyword. So we're going to see some more implementation of this later on in the video. First class, which will be the stack class. So for some reason, people aren't actually able to see this part, but I'm just right clicking, going to new class, and then we're going to be doing stack with capital S because that's what it's written as in the driver. So we'll do stack, finish. Okay, and now we have a stack class made. Okay, so we have stack. So let's go back to the requirements one more time just to read what we have to, what we actually have to implement here, and we'll go method by method. Let me actually close MS Paint too. Okay. So the first method that we'll have to do is public int size, and that returns the number of values which are currently on the stack. Okay, so let's try to implement size. I actually forgot to do one thing when I created the stack class, and we have to use the word extends. Dynamic array. The reason we're using extend is so we can actually connect to the dynamic array class and use the functions that were already created in dynamic array in our stack class. So we're going to make size. So we're going to do public int size. So remember, int is a return type and size is the name of our variable here. So we need our parentheses and curly braces. And all we're going to be doing is returning. Oh, sorry. Oh my gosh, return super dot array size. Now the reason we're returning super dot array size is because we already have a method. Let's actually go back to the parameters. We already have a method that returns the number of values that are currently in a stack. In other words, we have a method that returns the number of values, and that method is actually contained inside our dynamic array class. So let's go to it, and it's array size. So what array size does is return the size of the array. And so when we're returning the size of the array in our array class, we're just saying how big our array is. So if we want to know how big our stack is, we can just call array size on stack. See, this is the good thing about inheritance, is that we wouldn't have to initialize all these variables again. and we wouldn't have to rewrite this entire array size. We can just use super and get the functionality of this class into another class. That way we're being more efficient and saving lines of code because I hate typing. All right, so now that we have the first method created, okay, now that I messed up the first method, now that we have the first method fixed and created, let's move on to the next method. So we're going to be doing is empty. So this returns true only if there are no values in the stack. Okay, so we already have a method that tells us how many values are in our array, and we made that in the last program here. And that method is elements. So elements returns next index. And if you remember, next index is just the next available spot that an element can go. So if we have a next index of 5, that means that there are 4 elements in the array because the next available index is 5. So we can use next index to actually count how many elements we have in our array. So for example, if the next index is 0, that means that the array is completely empty and we can't put anything in there. So if we're writing an isEmpty method and checking if our array is empty, well, the first thing we're going to have to do is do public boolean and then the name of the method, so isEmpty. And now remember, we're going to be using boolean for this as a return type because we're returning true if the array is empty, and then we're returning false if it isn't. So we need boolean because boolean returns true and false. So we're just going to do an if statement to say if it's true, if we do have it, or if we don't have it. So if, and now we're going to use super again. Super.elements equals 0, return true. Else, and then we'll throw in some braces here, return false. Okay, so the reason we did this, the reason we called super elements here is because we wanted to use the next index variable, and we wanted to check how many elements were in our array. Elements, like the elements, what am I trying to say? The elements method already checked that in our dynamic array class. So now we can just use it in this class and change its functionality a little bit to make an isEmpty method. Basically, inheritance is kind of just like plagiarizing yourself. All right, so let's move on to the next method. Let's implement the next method here. Let's close up Eclipse. Okay, so we just have to do public void push, and this takes in an input of a double or of type double, and the name of the input will be value, and it just adds a specified value into the stack. So we actually did something very similar with the insert method. So we can start coding this up. Public return type is void, and the name of this method will be push, and this will take in a double. This will take a input named value, which is type double. So now we'll have to close this up, do curly braces here. All right. So now we'll just do super. Insert. And we'll do value. All right, and that's all we'll need to do. So right now, all we did is use the insert, and insert takes in a value. Just like it does in the array, the dynamic array class. Let's go find insert method real quick. There's insert at, it's different. So we don't need to type in all of this. We just need to use insert because this method is already created. And the reason we have to do value is because we have insert method already take a value here. So let's go back to stack. The value here will actually be used in this insert value here. So that's why we have this take a value of type double. That way this method will know what value is going to be added to the stack when we throw it in insert. So that's all we have to do for the push method. Now let's look at the next method. So it looks like we're going to do pop. So if the stack is not empty, remove and returns the most currently pushed value into the stack. Otherwise, return NaN. Okay. So we actually have an isEmpty method already created. So we can start by creating the method. So just public, return type is double, and the name is pop. Let's see, curly braces, classic. Okay. So we're going to use if statement. If this is empty, there we go, is empty equals false. We're going to return super.remove, else return double with capital D dot NaN. Awesome. Okay. So one important thing to know about this pop method is that we actually had to use we used the this keyword instead of the super keyword. So the difference between this and super is that when we use this, it refers to something inside of this stack method. When we're talking about super, we're talking about our main method or our main class or our super class, which is dynamic array. So when we do super.insert, super is just referring to the dynamic array class, and insert is referring to the method inside of dynamic array. This is referring to the method inside of stack, and isEmpty is referring to the stack method. So remember, we don't have a way inside of the main class to check if something's empty. We have a way to check how many elements we have, but we don't necessarily have a way to check if it's empty. So going back to the requirements, we have to check if the stack is not empty. Otherwise, remove the most currently pushed value onto the stack. So if this is false, which means the stack is not empty, we're going to remove the current value. And we did super remove because we have a remove method already built into dynamic array that removes the most currently pushed value, which is this one right here. So basically, we will just, it assigns a value to the array, then it nulls that value, and then it returns the remove value and shrinks next index, which is basically exactly what we need for the stack method. So instead of rewriting an entire method, we just use the super keyword to plagiarize ourselves, so we can save lines of code. And then for the else statement, we're just returning double NaN, because if we're not able to return if the stack is empty, we can't remove anything. So that is all the pop method will do. All right, let's go talk about the next method here. So we're going to be talking about the stack dump method. So the return type is void, and the name of the method is stack dump. So this prints all the values currently on the stack in the order that they would be popped off the stack. So this is actually a pretty interesting line that they said. So the order that it would be popped off the stack. This basically means, because if you think about our pop method returns the most currently pushed value into the stack, which means that if we're printing the entire array in the order that they would be popped off the stack, that means that we're actually printing this array in reverse, with the first available popped value to be printed first, then the second printed second, third printed third, and so on, which means that we actually are printing an array in reverse. So let's go back to Eclipse. We really can't use super. And the reason we can't use super, at least not right now, is because we don't have a method that prints an array in reverse. We just have print array. But if we use super.printArray, we're printing it in the opposite order that these values would be popped off in. Because remember, pop removes the current value, or pop removes the first available value. And right now, print array would print at the first element, and pop pops the last element, basically. So we could try, and what we should do is to actually write the method inside of the dynamic array class. And the reason we're going to write the method inside the dynamic array class and not the stack class is because the dynamic array class has access to the private variables that we're going to need. Because when we iterate through our array, we're going to need to use next index. And if you see here, as part of the assignment, the next index variable had to be made as a private int, which means that we don't have access in the subclasses, but we will have access in the class that these private variables were created in. So printing an array in reverse is very similar to printing an array the normal way. So we can just write it the same way. So public void, and then we'll give this its own name. So print, I'm a very creative guy, by the way, print array. That's crazy. Rev. Rev means reverse guide, in case that was very fast for you guys. So now in here, we're going to use a for loop, just like we printed the array the first time. So for int I, so this is going to be the different part. So int is actually going to equal next index -1. Oops, shouldn't have spaced that. Next index -1. And then I is greater than or equal to 0. And we're going to do I minus minus. And so in the body of this loop here, we're going to do system.out.print this dot array at index I. Not array size, just array at index I. So the reason we're doing this, we're printing this dot array at index I, is because we have to print every time we get an element, and we're going to start at the first or at the end of the array, and then we're going until we get 0, which is the index of our array. So we're starting at the front and going to the back until we get all the values printed. So now that we have this method created, we actually still have to implement it in stack. So in stack, it's actually going to be pretty similar to the size method. It's actually going to be basically identical, except instead of the return type being int, it's going to be void. So public void stack dump, because the name of the method they want us to create is stack dump. And then inside our braces here, we're just going to do super dot print array rev. So this is another reason why inheritance is so good, because inheritance allows us to use the private variables that we initialized up here without having to create a whole new set of private variables in the stack class and then having to rewrite all these methods. We can just use the functionality of the stack class, or the functionality of the dynamic array class in our stack class. So if you see how this entire line of code, or this entire method was 4 lines of code, pretty sure the other one was like 2 lines. We're just saving time, saving space, being efficient. That way we can go home and eat food faster or something. Okay, Anyway, let's go talk about the next method. All right, so let's go back to the assignment, look at the rest of our parameters here. So let's close out Eclipse and then look at the parameters. So it looks like we actually implemented all the methods that we needed to for the stack class. So now we can move on to the queue class. So again, we're going to want to extend our dynamic array class to implement a queue, which holds double values and adheres to the following. So we already kind of understand this concept from the stack class with extending the dynamic array class. And we're going to use size is empty, queue, dequeue, and queue dump. Okay, so right off the bat, we have at least 3 methods that seem basically identical. At least these 2 are actually identical, and queue dump prints all the values that are currently in queue in the order that they would be dequeued from the queue. This is the exact same thing. Ooh, actually dequeue is slightly different. Okay, I'm getting ahead of myself. Let's try to actually code some of these up. So right now we're gonna have to, the first thing we're gonna have to do is make our queue class. So let's go, you guys can see this, but basically it's just right click, new class, and then the name will be queue with capital Q. So QUE, what a funny word. Right. So make queue. And the first thing we'll do is extend this class off of dynamic array. So extends. Okay, now that we've extended it, we can start implementing our first method. So the first method that we're going to have to do is size, which returns the number of values currently on the stack. I'm pretty sure this is, oh. Okay, well, I guess it returns the number of values which are currently in the queue. So same thing, but I got slightly different wording, but basically the code is going to look exactly the same. So we're just going to do public int size, int return type, size is the name. All right. And we're just going to do the same thing. So return. So it doesn't really matter if we're doing stack or queue. Oops, there we go. It doesn't really matter if we're doing stack or queue for the keyword super, because we're extending, both classes are extending off the dynamic array class, which means when we use super, we're always going to reference the class we're extending to. So when we say super.array size, we're talking about the array size that's in dynamic array. Same thing with stack, because stack is extending to dynamic array. So in the MS Paint example, both boxes are connected to this dynamic array box as the super class. All right, so let's talk about the next one. We're going to do is empty, returns true if there are no values in the queue. Let's see if this is true. Yeah, okay, so basically the is empty method will also be the exact same. So we can do public boolean is empty. And then in the body of this method, we'll just do if. Let's see, super dot elements equals 0. I'm going to be returning true. Oh my gosh, return true. And then else, return false. We're doing this for the same exact reason as stack. It's the same parameters, it's just a different class. Oops, we have to go outside the method here. Okay. Let's go look at the next one. So queue adds specified value into the queue. Queue is going to work exactly like push. So we can do public void queue, void, and then this will take an input. Oops, hold on, I think I deleted a brace here. First of all, we need a brace here. Then we need a brace here. Okay, cool. So queue is going to take a parameter, which is a double. So it's going to take a parameter named value, which is type double. And then we're just going to use the insert method. So super.insert value. Remember, we're going to be using the functionality of our dynamic array class. So that's why we're using super insert, and then value will be the same name as the one we're inserting. So we're basically passing value into here and then straight into here. Okay. Now we're going to do the next method. I'm pretty sure it's dequeue. It is. So if the queue is not empty, remove and return the least queued value in the queue. Turn the least queued value into the queue. Okay, let me go. Okay. So we actually don't have a method for this either, because we're returning the least queued value into the queue. So we have a remove method, but we don't have a method, but our remove method removes the value at the end of the array. This method returns a value removed at the beginning of the array. So let's hop in MS Paint real quick just to explain what's going on here. Okay, gotta delete my artistry. So say we have an array here. Since we're doing doubles, I'm just going to use doubles as the example. 0.3 and 4.4. We can leave this space empty. It doesn't really matter, but we can leave the space empty. Basically, our remove method is removing the value at the end of our array. So in this case, if we call the remove method here, we're going to be removing 4.4. But we want our method to actually remove this value first. So 1.1. We want 1.1 to be removed instead of 4.4. So we're actually going to have to write a new method just like we did for the stack dump. We're going to have to do like a removed first type method. So let's try to make a remove first type method. All right, so here's going to be the logic. All right, so here's going to be the logic behind the remove first method. So let's say we have an array. Now, before I go over my logic, I would like to say that there are other ways to remove the first element in an array. This is just the way I achieved it. So let's create our array real quick. Just a sample array. Remember, we're using type doubles, so I'm just going to write doubles in this array. So this is 1.1, 2.2, 3.3. Very creative numbers, I know. 4.4. Let's make that a better 4. 5.5. Okay. We want the value 1.1 to be removed because it's the first element in our array. So what we could do is actually make this first element the last element in our array. So we can achieve that by swapping at indices. So we're going to swap the index at this index with this one, then move 1.1 down, 1.1 down again, until it's the last value here. And so our new array would look like 2.2, 3.3. Let's make the whole array real quick. 2.2, 3.3, 4.4, 5.5, 1.1, and then this would still be blank. So this is what our new array would look like. We're going to store this array. We're going to store this number in a value. So val equals 1.1. Then we're going to make this value null. So then we're going to do index. So then we're going to remove the last element of our index, effectively nulling this. And then we return. Oops, I spelled return wrong. Great. We'll return our value. So basically, we'll store this in a value, kill it, and then return the value that we stored in like this. So now that we kind of understand a little bit about how this code's going to work, let's actually try to code it up. So when we actually write this, we're going to write it in the dynamic array class. Just like we did for stack dump, we're going to have to write a remove first method. I mean, you can technically call it whatever you want, but I'm just going to call it remove first because naming things is very hard. So public, the return type is going to be double, and the name will be remove first. Like this. We don't need to take in any parameters, and we can use our curly braces. So we're going to copy some functionality from our remove method. So we're going to copy this whole thing right here. Yeah, we'll just copy these two for now. Let's copy these two. Just throw them in here. And now this is where the different part of the method comes into play. So our removed value, so remember, we're going to store the removed value in a variable. So equals, wait, actually. All right, now that we get the concept, let's actually try to code this up. So what we're going to do is public double remove first. It's going to take in no parameters, and we're going to do curly braces here. Okay, so the first thing we're going to do is look at our actual remove method that we made in our dynamic array class. And we're just going to copy these first two if statements here. I'm actually not entirely sure if we need to copy the array size and shrink functions here, but I'm just going to do it just to be safe. I'm pretty sure we do want to return null if we have an empty array. It might not show up, like that condition might not show up in the driver, but it's just better to be safe than sorry. So anyways, let's try to make our loop. So the first thing we're going to do is double. Before we make our loop, we're actually going to set our remove value to, oh my gosh, remove value. We're going to make a variable called remove value and set it to our array at index 0. So just like this. All right. Then after we make our value here, our double value at index 0, we're going to make our loop. So so here's the condition of the loop, int I equals 0 plus 1. We're doing plus 1 here because we want to avoid out of bounds errors. And since we're starting at the beginning of our array, we can't start at the 0th index. So we're going to have to start at the 0 plus 1 index. Then we're going to do I less than next index. And then I plus plus. All right. So inside the body of our loop, let me get rid of the semicolon here. Inside the body of our loop, we're just going to be swapping at each point. So we're going to say array at index I minus 1 is going to be equal to array at index I. Basically, we're just moving elements around until we move the last element in the array to the beginning. After our for loop is completed, we're going to do array at next index minus 1. Set that equal to remove value. This will be the value we're removing. And then array at next index we're going to null this, capital D dot nan as so, next index minus minus. And the last thing we need is the second last thing we need to do is capitalize I, and the absolute last thing we need to do is actually return something. So we're returning remove value. Okay, so let's talk about a little bit. Let's talk a little bit about how this code works. So we talked about in the last program how if our array can actually hold all the elements, we're going to shrink it to make it to use up all of the space inside the array. Then if the next index equals 0, basically saying that if our array is empty, we're going to return null because we can't remove an element that doesn't exist. Then if both, basically if we can remove something, then we're going to swap all the indexes. So basically we're going to move the last value to the front. Then we're going to make that our remove value. We're going to null that value and shrink the size of the array by 1 because, or shrink next index by 1, basically saying we have one less element inside our array because we just killed it basically. And then we're going to return the value that we removed. Okay, so now that we have the remove first method created inside our dynamic array class, we're going to have to put it inside the cube class. So pretty simple here. It's going to be public double. I think it was DQ. It's actually been a second since I looked at the parameters. Yep, DQ. So public double DQ. DQ. No parameters, curly braces, and all we're going to do is return super dot remove first. Like so. Oops. There we go. All right, now that we have DQ, we can go to our parameters here. And let me close MS Paint. All right, we can go to our parameters and look at our last method, which is QDump. So it just prints all the values currently in the queue in the order that they would be DQ'd from queue. So since DQ removes the first element in the array, we want to print the first element in the array, and then the second element in the array, and the third element in the array. And we actually have something that does the exact same thing in our driver already, and that is the print array method. So when we call DQ, we're removing the first element in an array. And when we print an array, typically, we just print the first element in the array, then the second, and so on. So we can do public void QDump. QU, he spells QUEE dump. No parameters. Throw in some curly braces. Oh. And it looks like I already had it typed, but basically we're just going to do super dot print. All right. I didn't know I had it typed already. But yeah, that's basically all we need to do. I'll just delete this. I'm pretty sure the only error is that there was 2 and there was. Okay. So now we have the Q class. Let me close this. I'm pretty sure the Q class is completed. Those are the only methods we need. And now let's take a little look at the driver just to see what's going on inside the driver. Okay. We create a stack object and a queue object. We fill the stack, and we're going to iterate 10 times 1 to 11. This might actually be 9 times. We're going to push values. Then we're going to call stack dump. Then we're going to empty stack while the stack isn't empty. So basically we're going to empty the entire stack. Then we're going to call my stack.pop. The popped values will print. Okay. So pretty simple. It's pretty similar to program 5 where they're just testing the functionality of each of the methods that we use. So let's try to run this and see if we are close to the sample output. Let's run it right here. Okay, so we're filling the stack. So 1.1 to 11. We have stack dump here, but it's printed sideways. Hold on. It's gonna bother me. Let's go to stack real quick. Oh, let's go to dynamic array. I think in stack dump, when we did array rev, yeah, there we go. We just need to put ln. That way it'll print top to bottom. All right, let's try running this one more time. There we go. Okay. We fixed, I mean, it was just a visual error. This stack dump looked the exact same. Or it printed the same numbers. It just printed them sideways instead of up and down. So anyways, fill the stack 1 to 11. Then go from 11 to 1. So we basically just got rid of it in reverse order, which is printing this array in reverse. We emptied the stack, got NaN, then we filled our queue, queue dump, empty queue. So let's see if this matches our sample output. 1 to 11, 11 to 1, 1.0 to 1.1, 2 to 21 twice. So 2.1 to 21.0 3 times in a row. Did we do that? We did. All right. So it looks like the functionality of this program is correct. So thank you guys so much for watching, and I hope you guys have a great day.